Late last week, there was a new satellite launcher that got its first tryout aboard the International Space Station. The device is known as Cyclops, and it helped with the deployment of a Naval Research Laboratory payload called SpinSat. And this morning, we're going to learn more about Cyclops from NASA's Cyclops Project Manager, Daniel Newswander. He is from the Structural Engineering Division here at the Johnson Space Center, and he's taken some time to come by and join us here to talk about that. Danny, thanks a lot for joining us, coming by.
You're welcome. It's great to be here.
Well, let's see. Let's start out by just a few questions to say, where did this idea come from? Why is there a need for this type of deployer when we have other ones that we've used in the past?
Well, that's a good question. Early on, it came from several engineers sitting in a room trying to come up with ideas to enhance or take advantage of the space station, the capability it has. It's a great resource, and we wanted to take advantage of that. We were aware the Japanese were building a CubeSat deployer. The CubeSat is a standardized cube, if you will.
Right.
But we were also aware of several satellites out there that were, if you want to call them, geometrically challenging. For example, SpinSat is a big sphere. It's about a 22-inch diameter, 52 kilogram sphere. So that doesn't really fit into a CubeSat deployer. So we came up with an idea to try to utilize, take advantage of as much of the airlock as we could, and take advantage of some of these geometrically challenging or larger satellites.
Well, you touched on it already with Japan being involved, obviously, but the Japanese and the Canadian hardware that's on the station, obviously there was a big development team, and you mentioned it. Who actually made up that team that you're on?
Wow. Yeah, we had a very
group.
We had a very big group. As you mentioned, we interfaced with the Japanese airlock, the robotic airlock. We interfaced with the Japanese robotic arm. The Canadian arm was another interface of ours. So there was a lot of interaction with their engineering communities, their operational communities. So there was a big international effort here. In essence, Cyclops is an international project when you really look at it. We also had a very extensive NASA team, engineers. We worked a lot with the International Space Station program with their engineers, their logistics, their operations, their payload safety. TOD, STP, the space test program that's here locally, they helped us get the satellites. SpinSat, as you said, was a Navy satellite, but they really helped us interface with that. They also provided a lot of experience and expertise to really help us be successful. So you're right, it was a huge team. It was it was actually my favorite part of the whole process, is interfacing with all these different entities and coming together as an international community and being
the teamwork.
Yeah, correct.
Let's take an opportunity, because the Japan Aerospace Exploration Agency provided us some animation of the procedure. So if you will, walk us through this while we look at it here, Danny.
Most definitely. So actually what you're seeing here is footage of the astronauts installing Cyclops and SpinSat into the airlock. I believe that is Butch. He's doing some final maneuvers there to make sure that everything's good to go. Once it's installed by the astronauts, it is processed through the airlock. And here you actually see some deployment, the deployment of the satellite. As you can see, it went off fairly smooth. It does have a little bit of a rotation to it. We were very excited at this point. I was actually speechless. We'd worked on this for about 3 years.
Where are you when this is going on?
We had a good team that supported down in the mission evaluation room.
Okay, so you're right below us.
We were there. We were listening to the whole thing. We heard the Japanese applaud as the satellite went off. This is the first time they'd used their small fine arm, or their Japanese robotic arm, and so they were extremely excited about this.
Well, obviously what we just watched was the actual footage from the preparation that you mentioned by Butch and the actual deployment. Now let's take a look at the animation, and you can talk a little bit through that procedure.
We can do it. Okay, so here's an animation. This is courtesy of the Japanese. It shows Cyclops and SpinSat coming out of the airlock, the robotic arm coming over and attaching to Cyclops and picking Cyclops up. Then what it does is it takes it out to its deployment position. It initiates the deployment, as you'll see here in a sec, and then that video we just watched previously where you actually see the deployment. This is what we envisioned it to look like. You did have a different angle in the previous one. Notice in the animation there is no rotation to the satellite. We did notice some rotation to the satellite. But
were you expecting rotation, or does it really matter in this case?
we weren't really expecting a lot of
I mean,
rotation.
you always learn something from
Yes.
anything that happens. I mean,
Yes.
but
One of the challenges of something like this is you're trying to develop a system down here on the ground in the Earth that you're going to be using up in space, and they don't always behave exactly like you think. So you put a lot of effort and robustness into trying to figure out all the variables, figure out all the things that could happen. And so, yeah, we were a little surprised about the rotation. There are a couple other things we were a little surprised about, but we're going to go off and work those so that the next satellites that use it, it'll be better understood and it'll be a better experience for
well,
everyone
that leads
involved.
me to my last major question for you, and that is, obviously you described already how that went and everybody's reaction to it, but so what's next for the Cyclops team in terms of future operations?
Cyclops is going to stay on the International Space Station. It was built to be there for the duration. And by the way, you're seeing a photograph here, and
That's beautiful.
That's my favorite photograph of all the ones you're going to see. And I kind of think of it as like when you see a sports team, a football team going out to get on the field and play, and they're all in the corridor there in the tunnel getting ready to go. It's kind of like, here we go. We've been planning this for years. Here we go. Great shot of the deployment. But pretty much what we built was for something to stay on the International Space Station, like I mentioned, for satellites in the satellite community that aren't the CubeSat variety, so they can use it. So it's going to stay up there and be housed inside the space station and be used for future deployments. We have 3 or 4 lined up right now that we're working with to try to get them up there, and we're very, very excited and anticipating their successes as well.
Well, Danny, I tell you, we're as excited probably as you, because we just love watching stuff like that and seeing the success of the program. And we really appreciate you stopping by this morning and talking to us a little bit about Cyclops. Danny Newswander, the NASA Cyclops Project Manager here at the Johnson Space Center. And so now let's take a look at the space station as a giant among Earth satellites.